Hello everyone. Today I'm going to be showing you how we can use our new Phoretix Array image analysis software to easily, quickly and most importantly accurately quantify enzyme-linked immunofiltration or enzyme-linked immunosorbent assays. Hello everyone. So today I'm going to be showing you how we can use our new Phoretix Array image analysis software to analyze an ELIFA, so an enzyme-linked immunofiltration assay, or an ELISA, an enzyme-linked immunosorbency assay, or basically any kind of experiment that is run within a plate that you analyze and you want to see some kind of color change or change in intensity. Our Phoretix Array software can do that. It is obviously, like all TotalLab software, equipment agnostic, so you can harmonize your lab using lots of different, if you're using lots of different plate readers or analysis machines, you can bring all of your images into Phoretix Array. It will accept them all and work with all those machines and harmonize your workflow within one piece of software rather than working with a fragmented lab system. So this software will work with basically anything, any image that presents your data in kind of an array, hence the name. I've just got an ELIFA assay here that I'm going to use for the demonstration, take you through the functions of the software, but it can be used with anything that is done within a plate, basically. So the first thing I'm going to do is come through and open my image. So I've got an example blot here. I open it up and you can see it's the image that I showed in the beginning. So just like in our Phoretix 1D image analysis software, we can see at the top left here a representation of our image where any saturated pixels will be shown as orange, aka pixels that have an intensity beyond the dynamic range of our instrument. We've got the ability to show a 3D view of our array here, which we can pop up into a larger size and get a 3D model of exactly what our data looks like. And we can export that as a presentation figure as well, of course, just like in our 1D software. We've only got one channel in this image. We can invert the measurements if necessary. And we haven't got an image here because I just need to edit the contrast of this image. So if I just hit the contrast button here, if I go on full, there we go. So just a little explanation over kind of the contrast settings, and this goes for Phoretix 1D as well. We've got gamma up here, which is pretty much a measure of kind of brightness, for lack of a better term. So we've got that controller there. By clicking full, the contrast is put at either end of the max of the intensity of the image, and when you choose auto, it selects a range within the center of the used intensities within the image. Now I'm going to go for full for this one just so you can see what I'm doing. It's going to change on an experimental and an image by image basis what your settings are. Sometimes you'll import the image and it will be perfect straight away. Sometimes you'll want to manually tune the contrast settings to try and visualize your image in the best way. So this image I'm using here as a demonstration is only an 8-bit image, so it's not the best quality. So here at TotalLab, we'd always recommend performing your analysis on a 16-bit TIFF image for the best quality analysis. So I've got my image here, and I'm going to keep it like this. So once I've kind of done my importing of my image, my editing of my image to make sure that I can see it and I think it's, good quality, I then come down to the grid setting. So because Array is designed specifically for experiments that are done in plates, typically 96 well plates or 384 well plates, to perform the analysis we use a grid style function. So, and this makes it much easier rather than having to draw individual wells within the software. It makes it much quicker and easier to give the user the ability to draw a grid. Now, we have a 96 well plate default grid and a 384 well default grid. However, we can change the size of this, number of columns, number of rows, to match whatever our experiment is. So if we were doing something within, I don't know, say if we had an image that had lots of small bacterial plates, we could do a 2x3, something like that. We could do a 6 well plate. There's a huge amount of flexibility built into the software to handle lots of different arrays of information in an image. So I've chosen a pretty simple one here, which you would do with an ELISA or an ELIFA, but there's a great amount of flexibility within the software to accommodate all of those. So left click 96, come across, left click and drag, and as you can see, it's starting to populate a grid of circles. So what we want to do is hold the left click, drag this across and release the left click, and you can see we're already starting to build up our volumes within our wells. So you can see we can control the size of the wells within the image here. Now these wells are quite large, so I'm just going to bring them down. If I left click on my edit grid, I can click and drag the corners of my grid to try and line them up better with my data. So say you've not got a perfectly square image, that's not a problem. You can start to bring this together. And if you do have a situation here where kind of some of your wells are off, you can edit the individual wells as well. So if you just left click on them, you can click and drag, and you can change the size of individual wells as well. You're not constrained to having every well be the same size. So if you did have an experiment where you had wells of different sizes, there's the flexibility within the software to cope with this. And whilst I'm speaking about the flexibility of the software, of course, being a TotalLab product, it's able to be integrated with our 21 CFR or GxP solution. So you can have, if you did want to harmonize your lab onto our software with all your different plate readers in a 21 CFR compliant manner, that's completely possible with our Phoretix Array software. So you can really you can have your operators trained in only one piece of software and maintain only one piece of software to do all of your analysis for all of your plate readers within a regulated environment. We've also got the option to have square wells if you're doing an experiment within a plate with square wells or circular. So I'm not going to go through and edit every single one of these, as I don't want to bore you, so you click off this video. So that's how you do it though. That's how you would make sure all of your wells are in place for your quantification of your wells. So I'm going to move on to the next workflow mode here, which is the background subtraction. Now, this shares some similarity with our Phoretix 1D gel and Western Blot, Blot analysis product, but it has some special kind of unique features as well, unique to this kind of experiment style. So just to explain what the background subtraction modes mean, surface minimum, the minimum intensity within each well is used as its background level. So what we mean by this is, say if I took this well for example, within this well, wherever there is the pixel of the lowest intensity, whatever the lowest intensity of pixel within this well, aka closest to white in this image, that will be taken as the background and applied to all of the contents in this well. What this means is essentially it will take the white around the well. And this is why your wells don't need to be perfectly sized to your data. In fact, it's a bit better to have them slightly wider because your background subtraction will accommodate for this kind of extra gap and will make sure you're not missing any of your data. Whereas if you have your well size too small, there's the potential that you're cropping out the intensity data around the edge of the well if it's not uniform. So that's what surface minimum does. Edge average takes the average intensity of all of the pixels around the edge of each well and uses that averaged value as the background level. So the average of all of these pixels where this line is the background. Much of a muchness, especially in this example where there's very obvious black and white. The surface minimum and the edge average would likely be the same value in this image. Negative control. Now, this is experimental based background removal. So say if I had, and there's a huge amount of flexibility here. So say if I had these first three wells were my negative control for the rest of my experiment. I could click this one and set that as the negative control. But I could also set this one as the negative control and set this one as the negative control. Essentially, if you've done your negative control in duplicate, triplicate, however many replicates you've done, if you select those within the image and then set them as the negative control, what the software will do is average the intensity values of those three wells and remove it from all of the rest of your experiment. So you can do it that way. And say, for example, I had, in fact, I'll come to that in a second. I'll continue going through the background modes, and then I'll go to kind of an experimental workflow that this might be useful for. So yeah, so that's how we would use the negative control background removal method, and that's how it's calculated mathematically. Image rectangle is shared between our Phoretix 1D product and our array product, where basically when you click on image rectangle, you're given this purple box, and it allows you to select an area, a rectangle of the image, that you want to define as your background. So this is a very manual background subtraction step. And you can also choose to have no background removal if you don't want any. So building on the negative control and the experimental workflow, say in this example, instead of having a grid, I wanted to consider this as an experiment of rows. You're not limited to just having one grid. So what I mean by that is, if I just get rid of this, if I want to have one row of 12 columns, if every row was a different experimental condition, for example, so I can have 3 grids and edit them all independently. If these 3 were the negative control for the rest of the row, and these 3 were the negative control for the rest of the row, etc., etc., you can consider them. You can do it that way, where basically you have it in a row by row basis, so you don't have to apply the same negative control as your background to the rest of your experiment for them automatically to be removed. So if I set this one, set this one, set this one, because those are all part of the same grid, they will all be removed from the same grid. However, it won't. The background value for these will not be subtracted from these results. But if I set these 3 as negative controls, they would be subtracted from these results. So that's kind of how that works and how you can use it in your experimental design to make sure that your controls are always included within your analysis, and how to kind of slice them up based on your experimental design. Moving through to the next workflow step, we've got the Normalising function, and this allows you to designate reference wells. So say if I had these 3 wells as a positive control, or as a standard, something like that, what I can do is left click on them and then set them as a reference well, and they will be, and I've got control over this, so I can set them as 100. So for example, 100%. So say they're my positive control, they're 100%, and I want to express all of my other results or values as a percentage of these, or as a fraction of these. I can do that by setting them to 1, 10, 100% example. So what we can do is we've got the ability to say to the software, do we want it to take the average volume of, say if I've got a positive control in triplicate here, do I want it to take the average volume of these and represent all my other results as an average of that volume, or do I want to take the total volume of these wells and then use that as my normalization factor to my other wells, my unknown results. If I come through to my quantity calibration, again, this is done just as it's done in Phoretix 1D. So if I have known quantities within my experiment, I can click on my wells, add them, say what the value is, so say 10, 50, 100, for example, say picograms of protein, and then I can fit a line to that as a kind of quantity, as a standard, as a known standard. And depending on how I've done my dilution or how my standards are set up, I can choose the correct line of best fit for that standard curve, for those known quantities, and then extrapolate and interpret my results as relative to those quantities. So I can express my, say, this well, say row 1, well 10, that's coming up as 127.2 picograms of protein relative to the standards that I've already told the software this intensity equals this level of protein. So that's how we do that, and we can also control whether we want to have an experiment, say it's a positive result or a negative result, aka is it present or is it absent? So we can control the threshold for presence or absence reporting manually using a sliding scale, which is a threshold set, or we can tell the software, look, this well is absent. It's my negative control, it's absent. And everything will be related back to that. So if there is an intensity greater than what I've set as my absent well, it will be reported as present. Likewise, if I mark something as present, anything below that will be counted as absent, will be reported as absent. So you can, if you're doing a binary experiment where you want to see if it's positive or negative, rather than analyze kind of an intensity or an accurate color change, you can use this. So that kind of things like bacterial growth, things like that, whether there's the presence or absence of an antibody or a protein or something within your sample. That's the kind of instance when you would use this feature. So you could say whether it is present or absent within your experiment. As ever, thanks for watching. If you'd like any more information about our Phoretix Array image analysis software, or you'd like a free trial of the software to see how it can help improve your workflow within your lab, please check out the links in the description below.